So how do we model this process of diffusion? Let's design a very simple framework for this, probably a kind of game. What kind of game? Let me again give you a scenario. This is a sunny Sunday and you wake up early in the morning and you want to decide how you are going to spend the rest of your day. And you have two options. Either you go to the library and finish that assignment whose deadline is coming this Wednesday, or you go outside, have fun, watch movies, do shopping and enjoy your day. Obviously, we would always want to do the second. Sitting in library and reading a book is boring, while going out and having fun is so interesting. That might be your option. Go out and have fun. But now let me broaden this picture and bring your friends in this picture. So now you have many friends. Let's say you have some 20 friends. Let me change your mind. You wake up this Sunday and you decide that you are going outside and you are going to have fun. But then comes into picture your 20 friends. And out of these 20 friends, 18 of your friends tell you that they are going to library and finishing that assignment which is coming up this Wednesday, and they invite you. And then here are your 2 friends which are asking you to come with them and go enjoy. Now what will you do? You might think for a moment, you might now want to go to library and finish that assignment. So how do we weigh our options? How do you weigh your options? Which choice to make? What to do? So the first factor which we have seen is how much that work interests you. So in this case, let's call it a payoff. There is a payoff which working in the library gives you, and there is a payoff which going outside and having fun gives you. And for you, the payoff which you get in the library is a little bit lesser than the payoff which you get when you go outside and have fun. First thing. Second thing, as we saw, the number of friends is important. What your friends are doing is important. So how do we capture this notion of friends? So let's consider one friend for simplicity. Let's say just one friend in the picture. So you have this friend Zara, and both of you have to make a decision what you both are going to do today. So one option, both Zara and you go to library and study, and both of you get some payoff which is associated with studying in the library. Another option, both you and Zara go outside and have fun. You get another payoff which is actually high because you enjoy more there. Remaining 2 options, Zara goes to library and you go outside. Probably you don't get any payoff because you don't go along with each other. And second option, the reverse way, you sit in library, Zara goes and have fun outside, again results in no payoff. So this tie, these 2 people, they get a payoff when they do the same thing, and the payoff is equal to the payoff associated with that particular thing. This was about one friend. So if you had only this one friend Zara, so the ideal situation, ideal decision you both should have taken was to go out and have fun. But the situation is not that simple. You have lot of other friends in picture. You don't just have Zara. So let's say you have some 20 friends here, and out of these 20 friends, 18 want to go and study in library and 2 wants to go and have fun outside. Now how do you weigh your option? So it's very simple. So if you look at every tie here, you are here and your friend is here, and if both of you go to library, both of you get some payoff. Let's say A associated with library. Similarly, here are you and here is the another friend. Both of you go to the library and you both get a payoff of A, and so on for all the friends. And similarly, if you look at the friends this side who are going to go and have fun outside, there's again, if you go and have fun, you get some payoff here. Both of you get a payoff of, let's say, B, which is associated with going outside and enjoying. And similarly in this case. Now what you will do is you will calculate the total payoff. If you go to library and study, what is the total payoff you get? And if you go outside and have fun, what is the total payoff you get? So for the time being, let's assume that the payoff associated with library is 2 and the payoff associated with going outside is 3. And let's say 15 of your friends are ready to sit with you in the library and study, while 5 of your friends want to go outside and have fun. So how much payoff do you get? This side is 15 into 2, 30. And how much payoff do you get the other side when you go outside and have fun is 3 into 5, 15. So what do you do? So you see that you are getting a better payoff when you are sitting in the library and studying with your friends. So you take that particular path. Let me change these parameters and ask you a puzzle, ask you an exercise question, and the question is again, assume that the payoff associated with sitting in the library and studying is 2, while the payoff for going outside and enjoying is 3. 12 of your friends want to sit in library and study with you, while 9 of your friends want to go outside and enjoy with you. So which action do you take in this place?